Vector View Window Part 1. To open this window, Vector View option from the View menu should be used. It is possible to open up to 5 vector views simultaneously. By clicking on the right arrow of Vector View icon, from the toolbar, desired number of windows can be opened. Here, the first vector view is opened. To better explain this window, first we close Detail View and Measurement View windows. In summary, on this window, it is possible to view current and voltage input and output values in different modes. Signal magnitude, the first harmonic phase, real value, imaginary values are displayed in Signal Magnitude Harmonic 1 phase, real and imaginary columns respectively. Also, the arrow of signals can be made hidden in the Show Arrow column, while the color of arrows can be selected from Color column. Moreover, to add the frequency column to this table, by right-clicking on this area and selecting Table from Show Hide option, the frequency column is added to display the frequency of signals. For example, VL1E signal with a 63.51 voltage and a first harmonic value of 63.51, phase value of 0, frequency of 50, real value of 63.51, and imaginary value of 0 is depicted with a blue arrow. Now, by changing the status of Show Arrow to false, you can see that the vector of this signal is made hidden in Vector View. To optimize the display of Vector View vectors, right-click on this section and check Optimize. If you want to manually optimize the display of vectors, first you need to uncheck Optimize option and then optimize the display of vectors from the related fields at the corners of this page. Also, if you want to add a signal to be displayed in Vector View, by right-clicking on the Vector section of this window, you should select or remove your intended mode to be displayed from the Show option. By default, only output value and actual are selected, and phase value and current values of the device are displayed. By unchecking output value and selecting Line Neutral, you can see that in addition to phase voltage and current values, voltage and current values of neutral point are displayed in table and vector as well. Also, if you want to display line-to-line values of output voltage of the device, you should select line-to-line from this list and check this option. Then you will see that the values of line-to-line voltage of the device are displayed in the above table, and the vector display of them is displayed in the below vector. If you wish to see the symmetrical current and voltages, select Symmetrical option, and by doing so you can see that the values of voltage and 0, negative and positive sequence flows and the vector view are displayed in the below table. By selecting any of the Power SV, Power SA and Power SC options, the value of power is calculated in accordance with the current and voltage of the test as well as different calculation methods and then displayed in the related rows. For example, by selecting Power SV, you can see that S1, S2, and S3 quantities are displayed in 3 rows. In magnitude, phase, real, and imaginary columns, the apparent power value, angle, active power, and reactive power are displayed respectively. Now, since here Power SV is selected, the power value of SV is displayed according to the formula in the box, and after being calculated according to vector method, it is displayed in SV row. Also, in PFV section, the coefficient value of apparent power is displayed. Now, if the user selects Power SA, the power value of SA is calculated using the calculation method and according to the formulas in the box and then displayed in SA field. In PFA field, the coefficient of power is first calculated using the same method and then displayed. If Power SC is selected, the value and coefficient of power are calculated using the algebraic method and the displayed formulas and then displayed in SC and PFC rows. You should keep in mind that S1, S2, and S3 quantities are the same in all 3 methods and displayed on the vector. Also, when the load is unbalanced, Power SC method works better than the others, and sigma V and sigma I parameters refer to algebraic sum of voltages and algebraic sum of current, respectively. Also, V and I parameters refer to current and voltage of the system, which are calculated in a 4-phase system using the displayed formulas.